In this short video, I'd like to give you a little bit more of an explanation of some of the definitions for a derivative and some of the content of section 3.1, introducing the derivative, and then I'd also like to do a couple examples for you. To start with, I want to clear up any confusion you might have between these two definitions, which are the same definition. It's just based from two different starting points, maybe is a good way to say it. Before we look at how these two compare, I want to clear up one short algebra piece. If we're saying that the limit, if we're evaluating a limit as x is approaching a, what we're saying is that if we have an x and an a, we're saying that the as x is getting closer to a, we're saying that this difference between them is getting closer and closer to 0. But if we define this difference between x and a, so how far apart are a and x, if we defined that distance or that difference as h, if we let h equal x minus a, then it would follow that x is equal to h plus a. Let me just show you that algebraically. If h is equal to x minus a, and you solve this for x, then what we're going to need to do is add a to both sides. Now, the a's cancel out, and we're left with x equals h plus a. So that's going to be helpful. Recognizing that algebra is going to be helpful when we look at the connection between these two definitions. So here we have the first definition. We're going to say that the slope of a tangent line at a point A to a function f is the limit as x gets closer and closer to a of f of x minus f of a over x minus a. When we say that x is getting closer and closer to a, what we're saying is that this distance between them, which we could describe as the difference, x minus a, but this distance between x and a is getting closer and closer to 0. But if instead of saying the distance from x to a, or the difference between x and a, if we just called it h, so if we let that difference be represented with an h, then x approaching a, so this x coming closer and closer to a, do you see what's happening to this green piece? This difference is getting closer and closer to 0. So as x moves in on a, this piece between them, the difference, is getting closer and closer to 0. So saying that calculating a limit as x approaches a, if we define h to be the difference between x and a, then limit as x approaches a is going to be the same thing as the limit as h approaches 0. Give that just a little more thought, look it over a little bit more, do a little algebra manipulation with that, and make sure you understand how we get from this initial definition to the alternative definition. Because these two definitions are the same, and here on page 113, we get a little more explanation of how they're connected. But it's just that we're going to define h to be this x minus a. So we're saying that x, as x is getting closer and closer to a, x minus a, we're going to say that that is the same thing as the distance between x and a getting closer and closer to 0. Let's look at an example that uses this definition, and this is an example taken out of the textbook, and it's example number 26. In your homework log, when you do a problem like this, you should start by writing the problem number, write the problem, and write the definition that we're going to use. So I'm going to write that the f of x is 1 over x at 0.11, and the definition we're going to use is that the slope of a tangent line is equal to the limit as h approaches 0 of f of a plus h minus f of a all over h. Now notice that f of a plus h is when we let a equal 1. When we let a equal 1, then f of a plus h, we replace this a with a 1, so we get 1 plus h minus f of 1. So this next step, when you see it, that's why it looks like this. So we have the slope of the tangent line is the limit as h approaches 0 of 1 over 1 plus h, that's f of 1 plus h, minus f of 1, which is 1, all over h. Now using direct substitution, I can't just let h equal 0 because I get a 0 in the denominator, so I've got to do some manipulation here. The manipulation I'm going to use is I'm going to simplify this fraction by multiplying everything by the denominator, 1 plus h. You see, if I multiply the numerator and denominator by 1 plus h, I've got to distribute that 1 plus h to both of the pieces of the numerator, and then multiply the denominator by 1 plus h. What it would look like then is the 1 plus h over 1 plus h reduces. If I distribute the -1 or the -1, I've got 1 minus 1, -1 times h minus h all over h times 1 plus h. Now these 1's are just going to cancel out because 1 minus 1 is 0, so I'm left with minus h in the numerator, and I can reduce that with the h in the denominator, and that gives me the limit as h approaches 0 of -1 over 1 plus h. And now I can use the direct substitution. I can let h be represented by 0. I can replace the h with 0, and I'd have -1. So I've found that the slope of the tangent line is -1. Again, we're doing this number 26. The directions ask us to now determine the equation of the tangent line. To find the tangent line, you could use the point slope equation or the y equals mx plus b slope-intercept equation. Either of these two to finish this problem. I'm going to use the point slope. So we've got y2 minus y1 equals m times x minus x1. So we'd have y minus let me make sure that everyone's with us here, that we've got the point 1, 1, right? So our y will be 1, And we've found that the slope was -1. And our x is also 1. Let me color code those just to make sure everyone understands where each of these numbers comes from, because this having two different ones, if you use this as an example later, might get a little confusing. So if you're wanting to review this to use it to do other examples, here's where each of those numbers is coming from. We've got y minus y1, so y minus 1, this one, equals m times x minus x1, where x1 is the 1. Now all I have to do is, let me eliminate that sub 2. All I've got to do now is solve for y. I'm going to add the 1 to both sides. I distributed this slope, the -1, add the 1 to both sides, and we'd get y equals -x plus 2. And that's it. The first part A, said to use the definition to find the slope. So part A, the slope was m equals -1. And part B asks us to find the equation of the line. So there's part B.